Okay, we are going to start uh, chapter number 6, the link layer and lanes. So the goal of this chapter is that we would like to understand principle behind link layer services. In particular, we will like to study error detection and correction schemes, sharing a broadcast channel that we call multiple access protocols, link layer addressing local layer networks, Ethernet, virtual LANs, and implementation of link layer technologies. Okay, so let's start. As we know that in internet, it is basically from nuts and bolts point of view, internet composed of nodes that can be like, for example, end systems and routers. Okay, so the internet, it consists of nodes means the host are routers, the host like laptop, mobile phone, vehicles, etc. Routers. Okay, so the internet, it is composed of routers and hosts, and these routers and hosts, they are interconnected through links. So basically the internet, it is composed of nodes and the communication links. The nodes could be hosts, or it could be mobiles, it could be servers, it could be vehicles, etc. And these nodes, the routers and servers, laptops, computers, they are interconnected with each other through links. Okay, so the internet, it consists of nodes could be host and routers, and the communication channel that connects adjacent nodes along communication path, we call it links. So internet it consists of nodes and links. So the nodes, the host, the routers, and the host and routers, they are interconnected with each other through links. We have discussed that this link, it could be a wired link and it could be a wireless link. Okay, so basically we have discussed it. Okay, so the data link, what is its functionality? So the data link layer functionality is to move the data from one node to another over the link. Okay, for example, if we move the data from here to here, so the link layer responsibility is to move the data from the one end of the link to the another end of the link. Okay, so the data link layer, it has the responsibility of transferring the packet from one node to physically adjacent node over a link. That is, it moves the data from the one end of the link to another end of the link. Okay, from the host to the router, from one router to another router, from another router to another router, and so on. Okay, and from the last router to the destination host. Okay, suppose, as you know that this is the node. Okay, the application, it generates the message is passed to transport layer. We know that when the message is received at transport layer, the transport layer, it add its own header. So this is called segment. The header plus the message, it becomes the segment. Okay, then the transport layer, it pass that message to the network layer. So similarly, the network layer process the message, and how it is processed, basically it add its header. So what is the functionality of network layer? The network layer first functionality is to compute. Suppose this is the host and it wants to send data to host C. So the network layer has to compute the path. Okay, for example, the network layer computes that the message from host A, it should be forwarded from host A to this base station, and from base station to the router, from router to next router, next, and so on. Okay, so now the network layer, it pass the message to the link layer, and it tells to the link layer that the data from host, it should be forwarded to this first router. It should be forwarded to this first router, and then it's okay. Now the movement of the transferring of data from host A to this first router, it is the functionality of data link layer protocol. Similarly, when the data is received at this router, so the network layer, it will compute the path that this data should be moved from this router to this router. So this network layer then informs the link layer that the data should be moved to this router, next this router. So then it is the responsibility of link layer, the data link layer, to move the data from this node to this node, okay, and so on till the data reach to the host C. So you can see the data link layer, its functionality is to move the data from source machine to the first router, from the first router to the second router, from second to third, from third to fourth, fourth to fifth, fifth to sixth, until it reaches to destination. Okay, so you can see that in this figure that the link from host A to this wireless access point, it is wireless, and from this access point to the first router, it is link. Suppose this is the coaxial cable. Suppose here the link is fiber optic. Suppose here the link is UTP cable. Suppose here the link is coaxial cable, and so on, so on. Okay, so you can see that when the data move from host A to host C, so the data may pass from the links, from different links. So maybe one link is wireless, another link is wired, another is coaxial cable, another is fiber optic, and so on. Okay, so now when the data link layer, it receives the data packets, so you can see that it adds it's moved the data from one node to another node, from one node to another node. Okay, now we know that the links, it could be wireless and it could be wired link, it could be wired link or it could be wireless link. Okay, so we have already discussed in chapter number 1 that the physical media or the physical links, they are guided media, which is called wired links. The signal propagate in solid media, for example copper wire, fiber optics, coaxial cable. Okay, for example this is the TP cable. Similarly, the media or the links, it could be unguided, like radio, wireless links, so the signal propagates free. Okay, so we have discussed that each type of link, it has, for example this is the copper wire, okay, this is the coaxial cable, this is the fiber optics. So each type of links, they use different technology, they have different bandwidth, they have different cost, and they have, therefore they are using different protocols, they are using different protocols. So we have already discussed this in the chapter number 1. Similarly, in the wireless links, okay, so this could be microwaves, which operates at 45 megabit per second. Similarly, it could be Wi-Fi, it could be cellular like mobile phone, 4G, 5G, or it could be satellite. Okay, so each type of media, it has its own characteristic, it has its own bandwidth, it has its own cost, and it has its own advantages and disadvantages. So we have already discussed it in the, okay, so is the data link types, they are of different types. You can see that the link, they are of different types. So similarly, the links, they, each type of link, it has its own protocol. Okay, so datagram transferred by different link protocol over different links. So when the data is moved from source to machine, you can see when the data is moved from host A to host C, so when the data is may pass through different types of links. For example, here it is wireless, here it is fiber optic, it is coaxial cable, it is UTP, it is coaxial cable. In each type of link, it has its own protocols. Okay, so the datagram is transferred by different links protocol over different links. Okay, for example, it can have Ethernet on first link, so it can have frame relay, protocol. So different links that they use different protocol. Okay, similarly it can have 802.11. This is for the wireless link, wireless Wi-Fi. Okay, so on each link protocol provides different services. Similar is that each link is of different types, each link has different protocols, and each protocol provides different services. For example, some may provide reliability while some will not provide reliability. We will discuss this later on. Okay, so what is the analogy of link layer? So what is, for example, the link layer functionality is to move the data from one node to another node. Okay, so its analogy in the, for example, if we are having a transportation analogy, for example, if a person want to move from Peshawar to Tianjin, China, so maybe the person move from Peshawar to Islamabad airport through uh, through a motor car, and from Islamabad airport to Beijing airport it may move by using the airplane, and from Beijing to Tianjin it can use the train. Okay, so the car, it is a free use from Peshawar to Islamabad, so it has its own characteristic. Okay, the plane, it is costly, the train, it may be cheaper. Okay, so you can see that from Peshawar to Islamabad we are using the car, so car is a different link layer protocol. Okay, so the link layer services. So as we know that when the message it moves from from transport layer, you can see that the transport layer it adds the header. So this is called framing, this is called that encapsulation, that the packet is encapsulated. Okay, similarly when the network layer it processes the packet, so it also add its own header, it's also in its own header. Similarly, so similarly to the transport layer, to the network layer, the link layer also it adds its own header. So along with the link header, the link layer also add the tail. So this is called framing, or this is called encapsulation, that when the link layer it processes the packet, so it add its own header, but as the header is added by the network layer and transport layer, but along with the header the link layer also add the tail. So framing means, so this is the first functionality of link layer, that it encapsulate the packet, it adds the header and tail. So it encapsulate the datagram into frame by adding header and trailer. Okay, similarly we will discuss later on that when the data is to be moved on the link, so first the link should be checked that whether the link is free or not. This is called link access. So before transmitting the data on the link, so the link layer has to sense the link, that whether the link is available or not. Okay, so if the channel the second functionality of the link layer is the channel access, the link access, if it is shared medium. So if the medium is free, then the data will be transmitted, but if the medium is used by another node, then the this node will wait. And third is that similar as we use the addressing at transport layer. Okay, what is addressing is used? The port number. The port number is used to identify the application. Similarly, the IP address is used at the network layer. Why? It is the IP address, it identifies the machine, the host, the server, the routers. Similarly, when the data is moved from on the link layer, the link layer addresses is used. This is called MAC addresses. So MAC addresses is used to identify on the link that which is the source and which is the destination. Okay, so the MAC addresses is used in frame header to identify source and destination. So this MAC address it is used at the link layer, so its scope is at the link. So it is different from the IP addresses. The IP address it should be unique. So it is responsible to move the data from source machine to destination machine. Okay, but the MAC address it is used to move the data over the links from the link one end to the another end. Okay, similarly at the link layer we could also provide reliability. Okay, the reliability protocol that we have already discussed in chapter number 3. So those reliability protocol, they can be used. We learned how to do this already. So this reliability, it is discussed in detail in chapter number 3, and we have done it. Similarly, when the data is transmitted over the links, so maybe there is the bit error. Okay, so on the fiber optics, the chances of bit error is very low. The chances of bit error is very low, but in the wireless links, the chances of bit error is high. So how we cope with the bit error? So with the bit error, we use the checksum algorithm, like for example we have already discussed. So in this chapter we will also discuss in more detail. Okay, so in case of bit error or in the case of packet loss, we are using the reliability protocol that we have already discussed in chapter number 3. So the reliability protocol that we have discussed in chapter number 3, they can be considered or they can be used at the link layer as well. Okay, similarly to reliability, the link layer can also provide flow control. Flow control means that the sending machine should send that much of data that can be accommodated by the destination machine, the adjacent nodes. So passing between adjacent sending and receiving node, that is, the sending node should send that much amount of data that the receiving node could receive. Similarly, we can use the error detection scheme. Why error? When there is the bit error, maybe this these bit error, they are caused by signal attenuation like noise. For example, as when a signal is moved, so maybe the signal have interference or a secondary wave propagation, etc. So due to the fading, the signal can become from 0 to 1 or from 1 to 0. So this is called bit error. So the bit error detection or the bit error correction mechanism can be used. Okay, another important characteristic is that a link could be half duplex or full duplex. A half duplex link means that the nodes at both ends of the link can transmit, but not at the same time. One node has to transmit, then other has to wait. Okay, but in full duplex, both sending node and receiving node, they can transmit both at a time. This is called full duplex. Okay, so what are the services of link layer? First of all, its functionality is framing. That when the packet is received, so it adds the header and trailer. This next is that when the data is to be shared, when the data is to be sent on the link and the link is shared, okay, then there is a second functionality is the channel access. Before sending the data, the medium, the channel, the link is sensed. If the link is busy, then the data will not be sent. If the link is free, then the data will be sent. So this link access, channel access, this is also the functionality of link layer protocol. And third is make layer addresses. For when the data is sent from the link from one node to another node, then it should be identified that which node is sending data to which node. So for this purpose, we use MAC addresses. The MAC addresses, its scope is totally on the link layer. And along with these three functionalities, the link layer could also provide reliability. It could also provide flow control, error detection, etc. Okay. Now we have discussed the link layer services. We are going to discuss another important characteristic. As we know that the computer system, it is linked with the link. It is connected with the link through the LAN card, which is called NIC. Okay, so in each and every host we have this NIC. Okay, so we have 5 protocols: application layer, transport layer, network layer, data link layer, and physical. The data link layer and physical layer, they are implemented within this LAN card in hardware. They are implemented in this LAN card. So this LAN card or this NIC, for example Wi-Fi card or Ethernet card, etc. So it has physical layer, it has a controller, it has a CPU and memory. So this is a full-fledged PCI. Okay, this is called network adapter card. Okay, so the link layer is implemented in the adapter, in this NIC card, in this LAN card, in this Wi-Fi card. Okay, for example we can have Ethernet card. Therefore, for each type of link. For example, for Wi-Fi we have to use a separate link card. For a coaxial cable we have to use a separate Ethernet card. For each link type we have its own link card. We have its own PCI card. Okay, so the PCI card, it is based, so because it is why that for each link we have different LAN card. Why in the NIC card, the adapter? Why? Because each link is using its different protocol, and the physical link and the data link layer, they are implemented in this LAN card in hardware. Okay, they are implemented in hardware. Therefore we know that that one of the functionality of the link layer is the MAC addresses. So these MAC addresses, they are also implemented here in hardware. They are born here in hardware. So therefore if you cannot change the MAC address of the LAN card. But nowadays the LAN card, they are in the firmware. Some part of the link layer protocol is implemented in hardware and some part is implemented in software. Okay, so you can change the MAC addresses in the LAN card. Okay, so the NIC card, for example, we have Ethernet card or we have a Wi-Fi card. So Ethernet chip is, so it implements both link layer and physical layer functionality here in this LAN card. Okay, so basically this LAN card, it is used to attach the host to system bus. Okay, because we have this link card, so through this link card this computer system is attached to the link. So this link is attached to the computer system by this LAN card. Okay, and this LAN card, it is basically connected in the motherboard of the system. So as I have told you that the physical layer and data link layer, it is implemented totally in hardware. Okay, but nowadays we have some kind of firmware. There's some part of is implemented in hardware and some part is implemented in software. For example, you can see that this is the 5 layers. So the physical layer and some part of the link layer, it is implemented in hardware in the LAN card, and some part of the link layer, network layer, transport layer implication, they are implemented in the operating system. They are implemented in the software and operating system. So that's why you can change it, no problem. Okay, but this you cannot change. Once it is written, then you cannot do modification. Okay, but why we do it? Actually, why we implement the link layer, physical layer in hardware? Because it is faster. We require here that it should be done faster. It should be done quickly with less time. Okay, so that's why we implement them in the hardware, but these, they can be implemented in software. Okay, so actually the adapter communicating, so and the sending side, you can see that when the link layer, it receives the datagram, so it encapsulates datagram into frame. Encapsulate means that it adds the header and trailer, and it also do error checking bits, reliability, flow control, etc. Okay, and then the data is sent over the link. On the receiving side, when the packet is received, so it looks for if there is error, if there is bit error handled or reliability handled or flow control is handled. So it looks for errors, reliability, flow control, etc. If the packet is received without error and is received reliably, it is received within flow control, so the packet is accepted, and then the packet is passed to the next layer, to the top layer. And which is the next layer? The next layer is the network layer. Okay, next layer, network layer. And if the packet has the bit error, then the packet will be discarded. If the packet is not reliable, it is with error. Okay, so the packet will be lost, and the receiving machine will send the negative acknowledgement. If the packet is received without error, then it will send the positive feedback. Okay, so basically when on the receiving side, when the packet is received, it looks for errors, reliability, flow control, etc. If these things are satisfied, then the datagram is extracted and the packet is passed on to the next layer, to the upper layer. And what is the upper layer? So the upper layer is the network layer. Okay. Now we are going to discuss another important uh, scheme for error detection. One of the important scheme is error detection and correction scheme. Okay. So before discussing it, we would like to discuss. So the first technique that is used for error handling, it is called parity checking, single bit parity. Single bit parity. Single bit parity means that it is used to detect single bit errors. Okay. How it is done? Suppose this is the data bits and we are using even parity. There could be odd parity and even parity. So even parity means that the number of ones in the data bit it should be even. This should be even. So the parity bit, this single bit is set to 0 or 1 depending on such that the total number of bits in the data and the parity they becomes even. For example, in the even bit parity, it means that this parity bit it will be set to 0 and 1 such that the number of ones becomes even. For example, you can see that here the number of ones are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is even, already it is even. So this value will be 0 such that if it is 0 then the total number of ones will become even, both in data and parity bit. But if it is set to 1 then the number of 1 will becomes odd. Okay, so this is error. So for even parity we will set this value to 0. Why? Because such that the total number of ones becomes even. So the total number of ones are already even, so it should be 0. If the total number of ones in the data bits are 1 are odd, then it should be 1. The parity bit will be 1. Then if it is 1 and this is odd, so 1 and odd, the total number of 1 will become even. Okay. So suppose we are using even parity. Okay. Now this data bit along with the parity bit it will be sent to the receiver. Receiver will compute again the parity bits. Okay. If the total number of ones are even, then it means that there is no error. There is no error. Okay. Suppose that this 0 bit, this bit, it has error. When this data bit and the parity bit it is transferred, so on the link it becomes 1 to 0. This bit is changed. So this bit is changed. This is called error. So suppose this will be the data received. So you can see that how many are the number of ones. The number of ones are 1, 2, 3, 4, 5, 6, 7, 8, 9. How many? 9. 9 are even. So the total number of ones are 9. The total number of ones are odd. So odd means it means that this data has error. Why it has error? Because the number of ones should be even, but here the number of ones are odd. So it means that this data bit it has error. But which bit is with error? So we cannot know it. Okay. So the single bit parity it is used to only detect the single bit error. If there is more than one bit error, then it cannot be detected. For example, you can see that suppose this bit is changed from 1 to 0 and this bit is changed from 0 to 1. So you can see it here, 0 and 1. So you can see that when this data bit and the parity bit is received, so you can see that number of ones are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is even. So the total number of ones are even. Okay. So if the total number of ones are even, so it is error free. But it is not error free because these two bits are changed. Okay. So it is error, but error cannot be detected. Okay. So that's why the single bit parity it only helps to that if single bits change or the odd number of bits change, then the error can be detected. But if the even number of bits are changed, then the error cannot be detected. Okay. Now we have another scheme which is called two-dimensional parity. Okay, what does it mean? So let's discuss it through an example.